Hello. In this video I'm going to create a multi-node Hadoop cluster in OpenStack using Heat and Ansible. In a previous video I used VirtualBox and Vagrant along with Ansible to create a multi-node Hadoop cluster, and this builds on that video. In this video I will cover how to use Heat to create the server resources for the installation of Hadoop, install and configure Hadoop using Ansible, start the Hadoop services and run an example MapReduce job, and finally, I'll show how to use Heat to scale up your Hadoop cluster. Some things I won't be covering in this video are how to set up OpenStack, how to create and configure a project or networking within OpenStack, or how to use the OpenStack CLIs. Here's a quick picture of what we're trying to accomplish. Within OpenStack, we'll be using Heat to create a master node and an arbitrary number of data nodes. Heat will orchestrate all of the internal networking, the assignment of floating IPs, and other connectivity details so that the servers are ready for installation. And then we'll use Ansible to install each node based on its role within the cluster. The instructions we'll be following are part of the README on the GitHub project Hadoop Multi-Server Ansible, which you're free to clone and fork and do as you please with. So the first step is to clone the repository, after which we'll open a console window in the directory where we've cloned the code. We then need to edit the Vagrant file and remove the unused data nodes. So in other words, we're using the same Vagrant file that we used in our multi-server or multi-node Hadoop cluster for Vagrant and VirtualBox. But the first thing we're going to do is delete data 1 and data 2, since we don't need those. Next thing we'll do is we don't need the master to be quite as big, so we can shrink that down. The only purpose of the master node in this scenario is as a box from which we run Heat and Ansible against our OpenStack environment. So we make those changes and save, at which point we're ready to do a Vagrant up. While that's building, let's take a quick look at the remaining steps. So after this step completes, and we have a running Vagrant box, we're going to follow the commented lines in the bootstrap master.sh, much like we did in the previous tutorial. We're using Python virtual env to create a virtual environment where we can install the OpenStack clients. And then we'll need to download the OpenRC file from OpenStack in order to establish command line access to our OpenStack environment. With our box built, we now need an SSH session into that server. So this is our local Vagrant server. And for convenience, we'll follow the commented lines in our bootstrap master file. So you'll notice that the virtual environment was already set up as part of the Vagrant up process. And the Heat client and other OpenStack clients were installed as well. So now all we have to do is activate our virtual environment, change into our source directory, and this is the directory that's been synced with our local checkout of the Hadoop multi-node repository from GitHub. Now I'm performing this installation on Helion OpenStack 2.0. So first I log in, and you'll see right now I'm consuming virtually nothing, so I don't have any instances. In the Access and Security tab of OpenStack, if you go to the API access page, you can download the OpenStack RC file. That's required for the next step. You'll see that the next thing I'm going to do is source that downloaded file, which queries me for my password, at which point I'm now ready to run the OpenStack command line client. Let me explain what's going to happen in this next step. We have our Heat template, which is heat-hadoop-cluster.yaml, and we need to gather some information that's specific to whichever OpenStack environment you're using to install Hadoop. So first we're going to get a key name. So that's the key pair we'll be using to access our servers. We need to provide an image ID, admin user, flavor, that's the size of the server, and then for the network, various values, as well as a security group that will accommodate SSH access. So in order to do that, we're going to run a series of commands. So OpenStack key pair list goes out to OpenStack and gets all of the key pairs that are available. OpenStack image list shows the images that are available in our OpenStack installation. OpenStack flavor list shows all of the flavors that are available. OpenStack network list shows information about both external and internal networks for this project. So internal meaning a private network. And then finally, we want to look at the security group list. So now we start the process of mapping these values onto our heat template. So let's start here. Let me see if I can move these around so it's a little easier to see. All right. So the first thing we want is our key pair. The next thing we want is the image ID. And for this, I'm going to use Debian. In the previous tutorial, you might have noticed that I used Ubuntu. So this will be a little different than that install, but we're going to use the Debian image. The admin user, in that case, is Debian. For the flavor, we'll do large. And now we need to get our external network, so that's the public network. We also need our private network, and we need our subnet. So hopefully that wasn't too fast. If it was, you can go back and maybe pause on those screens. The final thing we want is this SSH group. Okay. So with those changes made, we save our heat template. And keep in mind, this will be unique to whichever OpenStack environment you happen to be using when you install. And with those updates in place, a few other things you might want to check. Make sure you've updated the proxy details in group vars all. Make sure that if you need to, you've updated the remote user. So that would be Ubuntu or Debian in this case in the playbook. And then in Ansible SSH user, so in the heat inventory Python script, which you'll see used here in a minute, you may want to update the Ansible SSH user, which would be Debian in our case, and the Ansible SSH private key file, which is this key file that we identified in this first bit of our experiment here, which we identified with this OpenStack key pair list command. Okay, with all of those done, we're now ready to run our heat command. So just a quick recap, we're inside of a virtual environment. So we've activated a virtual environment where we know that we have the OpenStack and heat clients installed. We also have updated our heat Hadoop cluster.yaml file with details about our environment. And this command says I want to create a new stack, call it Hadoop stack, and base it on this YAML file, which is a heat template. Okay, you'll see it comes back and tells me the create is in progress. And within OpenStack, I can come to orchestration and stacks and see that the Hadoop stack is being created. When I look at the topology view, some of the things that finish first, for example, setting up a security group, setting up a port for the master server, and then floating IP for the master server are already done. And it's working on creating the master server and the number of nodes that we created. So now might be a good time to show you quickly. Inside the heat Hadoop cluster, there is a resource group. So let me scroll down here so you can see this resource group. In this resource group, which we call nodes, it's saying to use the heat data node.yaml and create 2 of them. So what we would expect when this stack is complete is a master and then 2 nodes. In a few minutes, you'll see that when it's time to scale the cluster out, all we have to do is change that count to whichever number we want, and heat will automatically add that many nodes to the cluster. And let me show you quickly what this heat data node looks like. It has a similar selection of parameters at the top, and then it defines a server, a port, and a floating IP address for each node in the cluster, as well as defining outputs for each node. All right, so the stack appears to be done. And if we look under resources and nodes, we'll see that nodes shows 2 separate servers. In fact, we can confirm that the servers were set up the way we expected by coming to our instances, and we see that we have a master node as well as 2 data nodes, and that they have both their private network and a floating IP address. They were assigned the key pair that we specified, and they're also based on the Debian image that we identified. Finally, you'll notice that Heat distributed these among different availability zones. So at this point, we have activated the virtual environment. We downloaded the OpenRC file from OpenStack, and we've used the command line client to update our Heat Hadoop cluster YAML file and updated any other files that were necessary. It's now time to run a few additional commands to ensure that we have the right connectivity. The first thing you'll need to do is make sure that on your Vagrant server, where you'll be connecting to these servers in OpenStack, that you have your key file. So we're going to copy that into place and make sure the permissions are such that it will be used when we try to connect. We then want to run heat-inventory.py. So this is a Python script, and I'll show you what this does in just a second. Running this script will build your inventory files used by Ansible. Let me show you what those look like. So now if we open up Hosts Pro and Nodes Pro, we see that in Nodes, it identified the 3 servers that were created. So these are the same ones, 72, 73, and 74. And in Hosts Pro, it identified the master node as having a .91 public IP or floating IP address, and it identified the floating IP addresses for the other 2 as 92 and 93. It also wrote a file called scan node keys, which will help establish connectivity to the servers that Ansible needs to access in order to install Hadoop. So that's the end of Heat. We now have servers running in OpenStack that are configured and ready for an installation of Hadoop. So now we simply run our Ansible playbook, which starts by configuring the Hadoop master server. The installation time is largely dependent on network bandwidth, the 2 biggest pieces of network bandwidth being the Hadoop download and the Java installation. After it's done configuring the master, it goes on to configure as many data nodes as were defined in the Heat template. In this case, we have 2. Now, one great thing about Ansible is that it runs these long-running processes like the downloading of Hadoop in parallel rather than sequentially, which speeds up the install time. Now that Ansible's done installing Hadoop, the next step is to start Hadoop, format the name node, and so on. But remember that in OpenStack, you have to first connect to the system where Hadoop was installed. So this is the Hadoop master on OpenStack. And we are connecting as the Debian user, and we need to connect to the master node, which is this IP address, at which point we're ready to become the Hadoop user, format the name node, we want to start DFS, and then start yarn, at which point we'll scroll back up a little bit and grab this IP address. We should be ready to see the data nodes, and sure enough we have 3, the master, data 1, and data 0, and information about our Hadoop cluster, including a listing of the nodes. And you can see our 3 nodes here, Hadoop Data 1, Hadoop Master, and Hadoop 0. We can now verify our installation by running a simple MapReduce job. And as that runs, we should be able to see that listed in Applications. And we could even click in and view the status of that run as the MapReduce job starts. So you can see its distribution across various nodes in terms of working containers. Okay, so now we've successfully used Heat and Ansible to provision hardware in OpenStack and install Hadoop and run our first MapReduce job. Let's say that we have a much bigger workload coming in. So we want a 10-node cluster. So like I mentioned before, we need to change this 2 to a 10 and save, after which we need to run stack update using Heat. So let's exit out of the Hadoop user and out of the master node. And we want to run stack update this time. So what stack update will do, we're saying we want Heat to do a stack update on Hadoop stack, and we want to use the same Heat Hadoop cluster.yaml file. And you'll see that it comes back and says, okay, update in progress. And in OpenStack, we can come and look at our stacks and see that Hadoop stack says update in progress. And if we click in and look at our resources, you'll see that the nodes shows update in progress. And in fact, when we click into our nodes, you'll see that there are now quite a few of these little new servers that are being built. So if we come into our compute instances, we should see all of these compute nodes in the spawning state. So we still have our master and Hadoop data 1 and Hadoop data 0, and you'll see that Heat was smart enough to continue counting from 1, so that we have data 2, 3, and so on up to 9, which will give us a total of 10 data nodes. It's also possible from the command line to show the status of your stacks in Heat. And for that, you do heat stack list, and it shows the stack, Hadoop stack, and the update was complete. And sure enough, when we come back and look at our servers, they're all available. So now, in order to add these into our cluster, we come back to our bootstrap master.sh, and we see we've now completed an update where we had originally done a create. So we want to rebuild our inventory files. So remember, right now our inventory file shows a single master and 2 data nodes. And our nodes pro shows a master and 2 data nodes. So we come over here and we run our Heat inventory script again, which you'll see has left us with an updated nodes pro and hosts pro. We also want to make sure that all of these systems are accessible from this Ansible host, or from the Ansible controller. So we scan our keys in, and now we want to run Ansible again. Now you'll recall that Ansible is idempotent, which means it should only perform the installation steps on hosts that aren't already configured, which is why for the Hadoop master node, we see that most of these show green. However, it did go in and build a hosts file that could now identify all of the new data nodes. And it will also prepare the known hosts entries for all of the new servers that need to be accessed from the master node. It's now identified the 8 new servers, and it's configuring those, but notice that it's showing data 0 and data 1, the existing data nodes, is green, because all of the install work has already been done there. While that installs, it's also interesting to notice that all of the new nodes were distributed as evenly as possible across availability zones. So we see availability zone 1, 2, and 3 all represented. At this point, we now have a full 10 data nodes plus the master node installed in our Hadoop cluster. Let's connect back into our master node. Become the Hadoop user, at which point we want to stop DFS. Essentially what we're doing is we're restarting DFS and Yarn services. So we also stop running yarn services. And we start DFS. And we start yarn, at which point we should be able to verify that we now have a full 11 nodes in our data node information. That's the 10 data nodes plus the master. And if we come and look at nodes in the Hadoop cluster, the nodes of the cluster, you see all 11 nodes show up. And we should be able to confirm that everything is working as expected. This time, let's start 100 MapReduce jobs and go through 30,000 cycles each. So it's going to create the input for 100 maps this time instead of the 10 as it did before. And we should be able to see this in our applications. And we can come in and look at the containers. I'll show up to 100 containers. You can see here that there are 84 entries, and these are distributed among data 0, data 4, data 7, data 3, and so on, across all of the various data nodes. And you can see how much work each one is doing. Even with that large amount of work, it happens very quickly across a 10-node cluster. In this video, we used Heat to create server resources for the installation of Hadoop, and then installed and configured Hadoop using Ansible, started the Hadoop services and ran an example. We then scaled that cluster from 3 nodes up to 11, or from 2 data nodes up to 10, restarted the services and ran a much bigger MapReduce job, showing how easy it is to install and quickly scale Hadoop for large-scale data processing. So head over to GitHub, where you can clone the code and duplicate what I've done. Thanks.